Okay. So yeah, so basically, let's look at the quartile one, right? Quartile 1%. Eva just pointed out is quartile 1 is percentile 25. Okay. So we're going to use a locator formula to locate the data value associated with the quartile 1. So right here, what is the sample size? How many numbers are there?
10.
10, very good. Brilliant. Okay, so K is 25, right? K is this. It's a percentile association. Now we good. So it's L equal to locator equal to N times K over 100. So if you put in numbers, so 10 times 25 over 100. So that's 250 by 100, that's 2.5. Do you guys still remember the rounding rules? What if it's the decimal number? What do we do? You're going to run up to the next whole number, right? Run up to 3. Meaning third data value is quartile 1. Third one. That means you go back to the
Professor, 1 second. Where you find the free n?
What? One more time, Eva, repeat your question. Which 3n?
What you circle right now? Free n. What does mean free n?
Third. RD means third. Yes. This is the same thing as third. Third number, right? That's what it means.
Ah, okay, thank you.
Yes. Okay, so that means the third number in our data set is quartile 1. So third number is 27. Right? So quartile 1 equal to 27. And the third number is what we call the quartile 2, right? Quartile 2 is the same thing as the median. So let's use a median formula to find this. So what is the median in this case, in this example here?
45 plus 35, 33.
45 plus 58, right? Which is going to be 50 number and a 6 number. No, actually it's 40. Hold on. How many numbers is that? 10, right? So it should be 50 number. 10 numbers. So middle 2 is 5th number and a 6th number. Yes. So you can average those two. That's a median.
Excuse me.
Sure.
How did you get Q1?
Oh, Q1 is same thing as a percentile 25. So quartile 1 is equal to percentile 25. You just maybe note. Quartile 1 is something percentile 25.
No, man.
Yeah,
I
and then
still don't
don't
understand what that means.
So remember you because you missed some of the lecture yesterday. So after you left, we talk about this topic, but it's okay. I'm gonna explain this one more time. Okay, so basically you have data set here going from minimum to maximum, right? And we're using 3 numbers, 3 quartiles. Quartile 1, so we split this entire range into 4 equal portions, 4 equal parts. So, so let's say here, this is the median, right? Median goes here, that's quartile 2. And then between minimum and quartile 2, we put another quartile 1 here. So quartile 1 separates. So quartile 1 is like the median of minimum and quartile 2. So there are 25% data here, 25% data here, and then quartile 3 goes here. Quartile 3 is the middle of quartile 2 and the maximum. So 25% of data goes here, 25% of data goes here. Does that make sense?
Yes.
It does. Thank you.
It's split into quarters, but okay, I was thinking out loud. Okay.
Okay, so that's why quartile 1 is like 25%. See, 25%, right? The mark of 25%. This This percentile is K, so we use a symbol K to represent percentile, a given percentile. But because it's 25 percentile, then K equal 25. The sample size is 10. We count two numbers here. 10 numbers. Yes, go ahead.
I have a question. Like Q1, it's 2.5, but we have to round up around 3.
Yes, that's right.
But if we have a result like 2.1, we have to around 2, or we have to.
No, you still run it to 3.
Okay, it's always bigger.
Always run up, always, right? Always
Okay, thank you.
run down. Very good. That's a very good question. So always run up. If it's decimal number, no matter what decimal that is. Yeah, so basically, that's why we get K here, and then we use the locator formula to locate the location of the data value corresponds with the percentile 25. So it's n times K over 100, so 10 times 25 over 100, and divide into that, get 2.5. And again, because 2.5, we run up to the third. Yeah, question?
Is Q1 always going to be 25 since it's broken up into 4 percentages?
It is. So this is a kind of like a general settings, right? For this quartile and the percentile problems.
And
Always
then,
true. Mhm.
and then, so the formula is N and K, and L equals N times K over 100. And
That's right. Mhm.
and that's what, sorry, and what do you find from that?
We find the location.
Location?
Locator here, yes. L here represent the location of quartile 1. Right. So we use it to help us find the location where the quartile 1 is located.
What does
basically
N
this-
and K mean?
N times K. That's just part of the formula.
Oh,
K is
okay.
the-
And so sample size times given percentile 25 or 100. And so the formula stays the same across all the province.
So this would be called the location formula?
Yes, so it's location formula. That's right, locator formula. L represent locator.
Professor, how do you find quartile 127?
Quartile 27. Yeah, so basically once we run up to the numbers, right, we go
Third
back to the
numbers. So 15, 23, 70 is third number. That's why?
so the third number. Yeah.
Oh, okay. Yeah, got
27 is the third
Got
number, right?
Thank you.
And that's why it's a that's why it's a quartile 1.
A is it this third number? Yeah, got it.
Okay, very good. And so that's quartile 1, we take care of that. And quartile 2 is a median. The median is the middle 2, right? We're gonna average the middle 2 in this case because we have 10 numbers. So you're gonna average, so quartile 2 equal to 45 and 58 divided by 2. So you add up those two numbers, you get 103 by 2. So this is 51.5.
4.2.
Yes.
You round that up as well.
No. In this case, we don't. Only for locators, right? We run down.
Only for what?
Only for locators. Only for L. For locators, we follow that special rounding rules. But if it's in the number itself, we do not. We keep as is. Make sense?
Yeah.
Okay, very good. So now, fourth one, again, fourth one is quartile 3, right? As you can see, quartile 3, if you accumulate those, it's a 75%. So quartile 3 is located, so Q3 is the same thing as saying percentile of 75. Right? So that means this is P75. Now sample size is N. K is 75. I use the locator formula. N times K over 100.
750.
That's right. 10 times 75 over 100, right?
Mhm.
And that's going to be 7.5.
Mhm.
But again, it's a decimal number, run up to next whole numbers. So become eighth data value, right? Eighth number.
8th percentile.
Right, that's an eighth data value in our data set is quartile 3. So
So
quartile 3. Mhm.
sorry,
Sure, go ahead,
is
Lisa.
n always going to be 10? Well, is n always going to be the number in the sample?
Yes,
Right.
yes, that's right,
So
always, right?
if it was 5, you would use 5. If it was 6, you would use
Mhm.
6.
N
Okay.
is always the sample size, meaning amount of the numbers in our data set. That's why we call that
Understood.
sample size.
I have a question. Wait, will
Yeah,
it always be 25 percentile? So
25,
times 25?
that's right. If it is 25 percentile, that's quartile 1, and multiply by 25. Now it's a 75 percentile, so I multiply by 75 here.
Oh,
Make
that's
sense?
the difference. Yeah, that's the difference right there.
That's right, Ricardo. Exactly.
Will we always be going by 25? Will we
So
always
it's like, sure, it's like 25, 50, quartile 2 is a percent of 50. Percent of 50 is like a median.
yeah.
So using the median formula, it's easier to get, it's quicker to get a result. We don't have to do all the calculations, right? That's why we take the shortcut of median to do that.
Yeah.
And then quartile 3 is always percentile 75. So K is always equal to 75. Then if you run up to next whole numbers, they just always run up to next whole numbers, get 8 data values. You take quartile 3, go back to the original data set.
Mm.
The 8 data value is 77. So 77 is the quartile 3. Okay. Is that clear?
Just, I think I missed, 1, 2. So we just we're counting the numbers.
Yes, yes. It's
Like
like
the
the
10 number.
index. So
But how-
locator is, sure, go ahead.
So it's gonna be the 8th number in numerical order or just the 8th number in the data set,
It's a number in the data set.
right? It doesn't have to be in numerical order. So,
It has to be in the increasing order.
oh, it has to be an
It
increasing
has
order.
to be, yes. Because it's already, it should be ranked, right? It should be sorted. And then
Right.
put into the increase.
Okay, I see, right, sorted first.
Sorry
okay.
first, exactly.
And then,
Sure,
That's
go
what
ahead.
I do.
Okay, then the next part, right? Next part is find the maximum, right? That's the 5th number. So in this case, the 5th number is, okay, I'm gonna put it somewhere else. Put it here.
So 1, 2, 3, 4, 45.
96, right? So the maximum is 96, the 5th number.
yeah, because it's the biggest number.
Exactly. Very good. So now we have 5 numbers, right? 5 number summary. Minimum is 15.
So
Quartile 1, 27. Median is this, right? Quartile 3 is 77. And maximum is 96. So that's all we need. So 15, 27, and 51.5, 77, and 96.
51.5 isn't on the summary, is it?
Yes, it's a median, right?
So
It's right here.
minimum, maximum, quartile 1,
No minimum,
idea, 55.
quartile 1,
Mhm.
quartile 2, which is
Yeah.
median, quartile 3, maximum,
Got it.
right? 5 numbers.
Mm,
That's why it's called 5 number summary. Yes. Is that clear? Everybody following this?
yeah, I think I got it.
Okay.
So,
very good.
I mean,
Mhm,
just to speak out loud. So
mhm.
we do the formula for Q1,
And Q3. Mhm,
Q3, and then whatever number we get, we round up and pick that number from our sample.
mhm. So
And then-
basically, mhm.
And then Q2 is the median, which you don't round, and then you just find the min and the max based on the chart.
Yeah, exactly. That's pretty much it for this question, right? But that's a That's another scenario. What if the locator is a whole number? So we have a standard like principle to follow. If you go to our Collabora course, open PowerPoint, let me point out to you. Let's go to lecture videos, PowerPoint. And we click on chapter 3, right? Lecture video. It's on the third part. Open the part 3. And the PowerPoint. I'll show you where that procedure is located. So you guys can always follow the same procedure. There are 2 different scenarios.
That's true. What is this? What am I?
Okay, let me open the file. And I'll share that PowerPoint video.
What time? I understand. Man,
Yeah, so let me share this. Okay, so this is the one, right? The part 3. You should have access to all of this PowerPoint. The one we are using here is this principle here. So we use this is locator formula. Once you use the locator formula, and then locator could be a whole number. If locator is a whole number, if it's not a whole number, that's the example we have over there. You just run up, right? Run it up to the next whole number, the next whole number, next larger whole number. If it's locator, it is whole number. You're gonna average out the next value. So for example, if let's say locator is equal to 2, exactly 2, that means for Taiwan, you're gonna average the second data value and the third data value. So the for Taiwan is the average of second and third number in our data set.
That's if we get a whole number, right? You said
Exactly, right. Yeah,
that's so silly.
but in our example, it's not a whole number, right? It's a decimal number. So you always run up to the next whole number. Does that make sense? So you always go by this flow chart.
Sir, can you repeat it again? Sorry.
Sure, go ahead.
I feel.
Yep, question?
No, Professor, just repeat this again.
Repeat this again.
Yeah.
Oh, yeah, so basically that's before this flow chart, right? If the locator is a whole number, then you're gonna average, and let's say locator equal to 2.
Mhm.
And locator only gives a location, right? It's like the index of the number, index of data values we're gonna use. So here is locator is 2. That means we're gonna average the second number and the third number in our data set. So quartile 1 is the average of the second and third numbers.
Okay.
And in the example we just did, right? We did it earlier. And locator is not a whole number.
Yeah.
That's why we run it up.
Rounded it. Yeah.
Run up the next whole numbers. So you go by this flow chart, right? In terms of the handling this
Okay. Thank you.
detailed calculations. But yeah, very good. Good question. Okay. So now we have 5 numbers. Let's put it in, see if that works. Let's put it into the our homework system. No, it's not this. Share. So it should be the other one. This one. Okay. Go back here and let's put in the 5 numbers. So 15 minimum, 27 for Taiwan, right? 51.5. That's going to be the median. And the next one is
77.
77, great, and 96, right? So, okay, and you check the answers is good, right? So now I'm going to show you how to construct a box plot based on this, okay, based on those 5 numbers, step by step. So I'm going to put it here. So remember we have a 5 number summary right now. So first one, minimum is 15, right? Second one, Q1 is 27. Third one, median, quartile 2 is 51. Fourth one, quartile 3, 77. Fifth one, quartile maximum. Now let's create a box plot here. With this. So you put a range here, put a line here, put a line here, represents minimum and maximum. So these two vertical lines, same length, right? Probably didn't do a perfect job here. Let me just maybe redo this a little bit. Yeah, you just redraw it. So you draw the networks. So you draw this line represents minimum, and this line here represents the maximum. So minimum here. In between, you're going to draw the dash line. That's what the first thing we do. So minimum is 50, maximum is 96. Now we see the total difference, right? Total difference is going to be for step 1 using maximum minus minimum. It's 96 minus 15. That's 81. Make sense? Now we're going to use this. This is like the 100%, right? Between minimum and maximum 100%. So now using similarly compare Q1 to minimum. If you use Q1 27, it's 15, so you're going to get 12. And now let's find out the location of Q1. We will do 12 over 81. That will give us a percentage, right? It will be 12 by 81. That's about 15%. It's 14.8%. So that's this is approximately equal to, so this is approximately equal to 0.148. And then if you want to do just approximately equal 15%, let's do that. That means the quartile 1 is located, is separating bottom 15% from the top 85%. So 15% is about 1/7. So you're going to split the entire line into 7 equal parts. So it's slightly bigger than 1/7. So the quartile 1 should be somewhere here. So you put in quartile 1, 1.7. Right here, this percentage here is 15%.
Now 51 would be.
So now let's look at the quartile 2, right? Median. Let's see where that is. So similarly, you do quartile 2 minus minimum. It's 51.1.5 minus 15, and this is 36.5. One more time, you're going to divide this number by 81. So 36.5 by 81. Let's see what that is. You guys can also put it into the Excel or the calculator. Get the answer here, 36.5 by 81. And that is about 45%, 0.45.
45%.
Yeah, supposedly, right? Remember, supposedly quartile 2 is a median, should be 50%. So that means now 5% of the data was shifted to the right-hand side. Does that make sense?
Yeah.
Okay, very good. So now 45%, let's say 50% is here, and 45% is a little bit short, 50%. So it's right here. That's a quartile 2. I'll put down the number 151.5. So now we find out the location of the quartile 2. Now C, let's find out location of the quartile 3. Similarly, compare the quartile 3 to minimum. And let's see, it's 77 minus 15, so that'll be 62. We're dividing 62 by 81. Let's see what that is. Let's get the decimal numbers. I mean the percentage here. 62/81. And that's about 77%. Okay, 76.5, so it's 77%. It's 0.765. So that's approximately 75%. So this is good, right? Meaning quartile 2 supposedly should be separating bottom 75% from the top 25%. And that's happening here, which is a good thing. So, so right here, quartile 3 should be 75% or something. Let's put down quartile 3, which is 77. Now I'm going to connect the middle 3 box, right? Turn into a box. And also, let me just erase. So you're going to erase everything in between, right? All of this between things. The points, dash line between, erase that. And also erase this. I don't need this. We're going to put in a solid line here in a bit. All right, so now let's go back. So you're going to connect this, right? You're going to connect this from the middle. So this is what they call a box. The full name is Box-Whisker plot. Yeah, we just basically call it box plot. And this is the procedure how we construct a box plot, right? Given those 5 numbers. Okay. Any questions? So basically from the box plot, we can see a lot of useful information. We can see the distribution of data values. For example, that 15% here, right? And between quartile 1 and quartile 2, that's 30% data. Between quartile 2 and quartile 3, that's 30% of data. And the last part is 25%. That means supposedly quartile 1 occupied 25%. So that 10% short is evenly spread into between quartile 1 and quartile 3. So that gives you the distribution of the data set. You know where the percentage of data value is located in different areas. And that's the biggest advantage of creating a box plot. You see the distribution. Okay. Now, okay. That's so since we went over this procedure, so I want you guys to try one of the questions in our Blackboard course, right? Let's go back to Blackboard course. And then let's go to the Excel demo. Okay.
Professor, I can ask, we have to come back for class assignments right now.
I'm sorry.
Right now we are come back class assignments.
Class assignments.
Yeah, right now we come back for this
Come back for
class assignment. We didn't finish yet, yeah?
right. We're gonna, yes. So you're gonna open this remember histogram practice solution.
I mean, I have to I have a questions about like homework. Several questions. I don't know how to find the answer.
Let's do this practice first before I'll go over your homework question in a second.
Okay,
I want you, yeah, sure. You practice this one first, and then I'll answer your open questions in a second, right? Okay. So let's open this file called. Everybody see that? It's called a. The file is called the histogram practice solution. Open that file. Remember, we created we have data set here. It's about Madanow's reference, right? So we're gonna use Madanow's reference to create a box plot. Okay. So you guys are gonna try that. I'm gonna give you 10 minutes. You guys can spend 10 minutes work on this data set.
I didn't see. I see just a Blackboard histogram practice.
Yes, that's a solution. Do you see a solution below that? That's a solution below that. You open the practice histogram practice solution.
I see. I mean, we have to open.
Yeah, open that file, right? That's where you get all your data values. Okay, make sense? Okay, now once you open that, you're gonna see this file here. Let's, let me show the file to you. Yeah, that's the file. No, not this actually. I'm gonna open it. Yeah, this is the file, right? Do you see this file? And what you can do is you can copy all the data values, right? Copy those all buffer 24 numbers here. And then if you want to do it in a paper, that's okay, right? Copy all these numbers, 3, 9, 11, 12, 16, all of those numbers. Put it on your notebook and can start analyzing this. So first of all, you get a 5-number summary. Maybe I can do this. Okay.
But they
Copy
have
this.
numbers already for the right side, no?
Huh? One more time. What's your
This
question?
have numbers, maximum, minimum, class, weight, round of up. This is have numbers, no? Or we have to
You-
find numbers 5, like a Q1, Q2, Q3.
Yes, right. We gotta find that. That's right. So,
Ah.
yeah. So we already know minimum, maximum. That's good because it's solid. The data set is solid, which is a good thing. Yeah. So let's see. Did I share the screen? Okay. Let me see.
You want a 5-point summary?
Yes, 5-point summary. Exactly. 5-number summaries. So come up with the 5-number summaries first. A second step is the first thing you do, right? Second thing you do is create a box plot. Okay. I'll give you 10 minutes and then we will go over the solution together, right? This is a real data set. Let's see if we can come out with a box plot from there.
Professor, I can find this file. It's task 3 or task 4? Task 4, yeah?
No, it's you go to Excel demo, right?
I will go Blackboard. Then
Yes,
I
go
will
to Blackboard, go to Excel demo. Right? And you
I don't
open it.
see lecture and video, and then task 4.
No, Excel demo.
Excel. I see.
Excel demo, and then you open the histogram fractal solution.
Okay. Right, fine. Yes, sorry.
Also, if you cannot find that, you can use the data set here. I just copied the entire data set, right? And you can use this.
I found.
Okay, very good. Use that. Okay.
This is an unrelated question, but our midterm will be on Lumen, right?
Yes, we are human, exactly. It's
Okay.
already, I already created. I just didn't release it yet, right?
Huh?
No, I didn't, I mean, I already created midterm in Lumen. Yes,
Okay,
so your review will take place if you missed yesterday's class. We will review on June 15, right?
okay.
Mentioned yesterday, Thursday, June 15. And yeah, that's next Thursday. And then your midterm will take place on June 20th. You're gonna go to one of the computer lab. Yes, no, June 19th is a holiday, so yeah, we don't have class, so June 20th.
So the midterm's on the 20th?
That's right. 19th, June 19th is a holiday.
All right, thank you.
No problem. And then also, the room we're gonna go, right, will be F for the midterm, we're gonna go to F 507. It's a computer lab. So you guys don't wanna bring your own laptop, that's okay. There, desktop in my room, you guys can just come in and use the desktop in the computer lab to finish the midterm. And all the exams, right, midterm final, you're allowed to use formula sheet, calculator, right, formula sheet. If you want to print out that, that's good. For the midterm, secondly, you can use calculator or Excel, or Excel, right? You can use both if you want to. But no book, no notes.
Professor, we have to draw a box too, or
Yes,
just find
draw
the
the
numbers?
box plot, yes.
Ah,
Once you finish this, draw the box plot. Okay, box.
okay.
Yeah, okay.
Excuse me, Professor.
Yes, do you finish it?
Almost,
yes.
but I had a
Almost,
different
okay.
question.
Sure, go ahead.
Would you mind after the class, for like 5 minutes, if you can just show me something with the standard deviation? Because for some reason, I don't know why I'm getting it. I'm not understanding it completely.
Okay, no problem, yeah.
Thank
You can stay after class, right?
Yeah,
Go over your question. No problem.
yeah, after class, yeah.
Yeah, after class.
Thank you.
Okay, sure.
Standard deviation and the variance, I'm just not getting it.
Okay, no problem. Yes, stay after class. I will explain a little bit more to you.
Thank you.
Sure.
But can you also help me with that too? Because I'm kind of confused with standard deviation as well.
Yeah, maybe, you know what? I will just maybe go over another couple questions like that. And after you finish this one, I go over the solution, we can look at more questions like that. If that helps. So do you finish yet? The question, for this question,
Almost.
almost, okay, couple more minutes. All right, we'll go over solution. Yeah, so that's resume, right? Let's go over those right number summaries first. So the minimum, let's find the minimum.
It's
It's
three.
3. Very good. You might get a quartile one.
It is 16.
Okay, let's see. So, what's the sample size here?
24.
24, great. Now what is the K?
25 for quartile 1.
Very good. So the locator equal to E times 3 over 100. We get 24 times 25 over 100. If you simplify, you get 6, right? So this is again, it's a whole number, right? It's not a decimal number. So what do?
I added 16 and 21
Yeah,
and divided it by 2.
2.
Right. So we're gonna average the 16th and no. Okay, we're gonna average 6 data value, right? In this
Yeah.
case will be 16, 121, 7, right? Very good. So average of the 16 and 21. So quartile 1 equal to 16, 21.
Professor, I didn't understand why we're supposed to be like last time. We didn't we do only Q2. We Q1 it's 6. It's 3, 9, 11, 12, 16. It's mean second 16. Why are we supposed to be plus 4?
No, it's not a second or first. This is like this locate the formula only give a location of the
Yeah, location
of the
number 6.
quartile 1.
What we do last exercise, it's number 6. We count number 6 in data set. Number 6
Yeah,
is
because last answer locator is a decimal number, so you're gonna run up the next whole number. But in this question, the locator is a whole number. Because it's whole number, that's why I show you this whole point here. If it is whole number, you're gonna average. So L here equal to L equal to 6, right? I'm gonna average 6 data value and 7. Average those two. So quartile 1 is average of 6 and 7 number.
why it was different the first time when we found in the class of segments.
Because first, the other one, okay, 1 second, I'll show you. Because you get a decimal number here. And
Yeah.
this decimal number, you're gonna run up. Right, so you handle the whole number and decimal number differently. That's why there's a flow chart, right? Just for that. That's why I show you the flow chart here. You see, if it is not a whole number, run up. If this whole number, you could average the 6th and the 7th number in our original data set. Yes, if you really read through this information here, actually that gives us the direction to find out those. Yes, that's why we're going to average the 6 number. This is 6, and that's a 7. Right, so you average those two numbers. Is that clear, Eva? Following?
Yes, it's clear, but it's everything wrong what I did before. And a number Q3, it will the same if we
Yeah, it's the same.
Oh,
Yes,
we
it will be
have to-
similar.
Okay.
Right, it will be similar. Right, okay. We get to that in a second. So 37 by 2, that's 18.5.
Professor, I just want to know so I got this right.
Where
Yes,
we
Ricardo.
count 4? I don't understand where we count 4 if we have a 21 next. Why we have 16 plus 4?
What do you mean? Where do you see 16 plus 4? That's 21.
It's 21. Okay, right now.
Just maybe just a writing, you know, it's 16 and 21. Already circle that. Yeah, Ricardo, you have a question, right?
All right, yeah, there's well, more like I'm saying, there's two parts of this. First, we find the locator. That tells us
Exactly.
where in the data set our number is located. the number we're gonna use, right? So
Mhm.
find the sixth and seventh numbers. And, okay, so that's the main part right there. I was confused with what the locator was. We're just locating the number in the data set.
That's right, exactly. So that's what the locator is about, right? It's location. It tells us location. Yeah, so we get that quartile 1, right? Anybody find quartile 2 or median? There's a median. Okay, so this 7, 8.
It's
Okay.
28.08.
Very good. 28.08. 28.5, right? Yes, 28.5.
5.
Right, exactly.
Yeah,
So
got it.
the middle two is those two numbers. Makes sense? Yes, will be the 13.
Oh,
number, and then
I
14.
found the mean by accident.
We're using median, but it's okay.
Yeah.
So the median here will be the average of those two. So quartile 2 is equal to average of those two numbers. Which is the value. We use different color. So quartile 2 equal to 27, 30,
Mhm.
2. This is 57 by 2. 57 by 2 is 28.5.
5, yeah.
Yeah, very good. So now when I get to the quartile 3, that's a percentile 75. Now one more time, we have sample size 24. K is 75. And using locator formula, n times k over 100. Yeah, so it'll be 24, 75, and 100. And to simplify, we get 72 over 4, which is 18.
18, yeah.
So again, it's a whole number, so you can average 18 data. Which
So
number
it's
is 18?
32
data?
plus 36.
Exactly. Those two, right? That's 18th and 19th. The average 18th number, 19th number. That's quartile 3. So quartile 3 is 32, and then 36, 3. And then you get 68 by 2, 33. Okay, so we get to the quartile 1, quartile 2, quartile 1, quartile 3. And also last item, no calculation needed. We find out what 59. Okay, so now based on those 5 numbers, so let's create a box plot. Right? One more time, let me just put in a different colors and distinguish them. So first of all, you draw the line, 2 lines, right? It's like 2 lines separating the minimum. Minimum goes here, maximum goes here. And you can put a number below that. If that helps, you keep track of everything, right? So first, step 1, we're going to find the difference between maximum and minimum. And we find the difference is 56. So the
Professor,
total- yeah, sure, go ahead.
I have questions.
Yeah.
About medium. Why it's supposed to be 27 plus 30? Because 27 is 12 number.
No,
And
13th number. You see
Uh,
that 227.
yeah, but it will be 30, it will be 14 number.
Yes, the 13th and the 14th. Those are the middle two. Make sense?
No.
There are
Like
12
if
number.
24 are like 12. It's middle if the 12, 27 and 27.
12 and 13. Oh, maybe you're right. Let me see. We may made a mistake. Let me see. Let me double check. Maybe you're right. How many number about it?
Like it's supposed to be 12 from the up, 12
Oh,
from
yeah, you're right. Yes, you're right. So that's a, yeah. So, yes, I overlooked the Eli. This should be the average of both myself.
Right. Right.
Okay, so good catch, very good. Sometimes, too many numbers, you lose track. That's what happened to me.
Okay, I'm glad
Yes, you're correct.
yeah,
come back to it.
one things from the whole mathematics.
That's great. Yeah. So yes, actually, those are middle two. Right. Those are middle two. So you're gonna average 27, 27. Turn out to be 27, right? So quartile two is actually 27. Great catch. Almost made mistake. Otherwise, our box plot would be skew a little bit, right? It's not a. Okay, good job. And okay, so now we're gonna do Q1 minus minimum. So that's going to be 18.5 minus 3, yeah, 15.5. We're going to divide 15.5 by 56, right? So to get a percentage, so 15.5 over 56. Let's see what that is. So 15.5 over 56, and that's about 28%. It's approximately 0.28. Right, that's
I have a
about 20.
question.
Sure, Risha.
Why are you doing this formula if we already found the quadrants? If that's or quartiles, whatever they're called. Why are you doing
That's
that?
right. That's so the quartile, the breakdown, that's ideal scenario. But in the real world, nothing is ideal, right? Like this data set is not ideal. Not 25% data between minimum and maximum.
So are you finding this percentage to know where to plot it on the graph?
That's
on the
right.
box?
We want to locate a accurate location. We want to find an accurate location for quartile one, and then we get to use the actual data, right? Actual number we get from finding the summary. So in that case, we have a better idea where the exam location is in reality. And the one I showed you earlier, that was like ideal breakdown, meaning in the ideal world, that's what happened. It's supposed to be 25%, 25%. But the most of the time, if that we have a real data set, that doesn't happen. That's why box plot helps us understand the distribution. Not the ideal one, right? We know ideal what the ideal one look like. It's all 25%. But when you have an actual data set, it varies case from case. That's why this box plot becomes useful to compare different data sets in terms of distribution. Does that help you understand the purpose of this?
In some way, yes. I'll just keep following along.
Okay, so basically, in this particular data set, quartile one is separating the bottom 28% from the top 72%. Supposedly, the quartile one separates the bottom 25% from top 75%. So that's extra 3% of the data is being shifted between minimum and quartile one. That's something we see from this box plot, right? So that's why we need this. We need this calculation to accurately plot those three index: quartile one, median, and maximum, and then quartile three. So now we can draw it. Use a different color, just in the middle. Yeah. Meaning, let's draw a dashed line here between those.
Professor, we can do it like not 28%, like 30%.
No, we can't. It has to be approximately right? If you run it to 30%, it's a little bit too much. You're shifting another 2%
Okay.
of the region. That's not a good idea.
Mm.
Yeah. So again, you split it. It's like half, and it's like a quarter, right? But it's a little bit more than a quarter, so it should be right here. So Q1 goes here. If you put a number below it, it's 18.5, which is good, right? And then we move on to second step, like doing quartile two minus minimum. And that's going to be 27 minus 3. That's 24. If you divide 24 by 56, we're gonna get a percentage, approximate percentage. What is that? 24?
It will be 43%.
Exactly, great. 0.43, so that's approximately 43%. What does this tell us?
To be low because the Q2 is supposed to be 50, but it's
Yes,
43.
supposedly here, but now it's shifted here. That means now 7% more data values were shifted towards the right half, right? To the right hand side.
So
this is
if we were
Q2.
giving this on a test and like we had to like write out like the box graph, or we're just like estimating, right? Like where we would believe 43% would be, and like
Yes,
18.
unless you have a ruler, you have a ruler like tools, and you'll be more accurate. But
Oh,
right
okay.
here, yeah, so again, it's just it's a approximation. It's not a 100% accurate graph. Okay, I don't have the tool, so I can't get an exact graph.
Okay, I was just making sure.
That's right. But if you're a ruler, then you can get a much more accurate graph, right? Just measure the total length, then you multiply by the total length here, by the percentage, then you'll be able to measure the exact location. Okay. Yeah. Yeah, I think you get the idea. We're just gonna see a approximate like distribution of the entire data set. And that's what we try to do. And this is actually 27. So we located quartile 2. Now then let's locate quartile 3. Minimum. So that's gonna be 34 times 3, 31. 31 over 56. Let's see what that is. And that's about 55%. Is that right? Yes. That's 0.55.
I'm sorry, Professor. I
Yeah.
just have so many questions. I'm sorry, but
Yeah, no problem.
why are you
So
dividing
far.
by 56 if the max is 59?
No, it's a difference between maximum and minimum. The
Oh,
difference-
okay.
Yeah, that's like a
fine.
range, right? That's like the base we go by.
Oh, so you divide by like, okay, the range, gotcha.
Always,
Sorry.
right? Always the range, all the time, right? Same number, see same number here. Same. That's where we base on, right? It's like the standard units right there between the minimum and maximum. So that's 55%. This is 50%. 55% is just a little bit more over this, which is, so that means this box plot is very skewed. Does that make sense? We have like 45% of the data between quartile 3 and maximum, right? Ideally, it should be only 25%, but we have additional 20%. So it's like very skewed. The data set's very skewed to the right, right? Most of the data values was, actually it's just skewed to the left because most of data values are concentrated on the right. So you're gonna see something like this. This is like the skew.
Yes.
No, actually, yeah. Let me just draw the graph. If you draw, it will look like this. So the most of the data value was shifted to the other end. Still didn't get a very good graph here. Something like that. Right? So it's shift to the right hand side. So that's what the skewness. So you can see the skewness here. Now one more time, we're just going to delete all of this. So just erase all the dash line between, so we can get a true box plot. But again, this is useful when you analyze the entire data set, but typically you don't have to do this in your exam or in your homework. Just going to show you this skill. It's useful to analyze the real data. You can also see the distribution here. Right. Okay, any question about this? All right. Now, since a lot of you guys have a question about the standard deviation, I would might go over some of the questions from the standard deviation in the homework assignments. Let's go there. Okay, so let me just go back to our website first.
Did we finish reviewing the entire in-class and homework?
Yes, we did. We did. In-class assignment is completed. We just finished question 7 earlier. Remember, I recall this. If you join the meeting late, it's okay. I'm going to send you guys this recorded video so you can review over later. Okay. I will produce this video and I will send it to you. I will also post it in our Blackboard course later. Yeah, let's go back here. I just produced the video for my morning class. This is the video I just created. This should be a YouTube video, right? You guys gonna get a YouTube video as well once I finish producing. Okay, let's go back to the Lumen. We did this all the way to question 7, right? It's a
Question.
yeah. So this is an in-class assignment.
Okay. Well, sorry.
Right. Yeah. Now let's look at the homework assignment. Since you guys have a question about the standard deviation, the variance, let's look at one of the questions here. Let's do it together. Let's see. Most of them are mean, median, mode. I mean, some of them have mean, median, mode, and standard deviation. I think this is a good one.
Can you open my my homework, because like everywhere different number, but I know the formula, I know how calculate it. I did like different exercises in the homework, but number 6, I don't know why I can't found.
If you want to do that, then stay after class. If you want to
Okay,
look at your question, then stay after class.
okay, I will stay.
I'll end the class slightly earlier today, so stay after class. I will go into your account and then pull out your question. But let's look at this together so everybody will be on the same page, right? Let me just copy this question right now very quickly. So we have a data set with 7 numbers, right? How many numbers? 2, 4, 6, 7 numbers. Let's do a quick analysis here.
It is 28.53 and it's correct. It shows it's correct.
28 point. I mean the mean.
It's mean 28.5
Right. Mm-hmm.
and
Yes,
standard
yeah.
deviation is 12.07. But I can't find variance, but I know the rules and I Excel it, I calculate it.
Okay. Yeah, no problem. So I'm also going to show you guys, like since you already did a calculation, I'm going to copy this and then paste into the Excel, right? So you guys can see what happened there if you did it in Excel. Okay.
We're squaring the X values, the sample values.
Exactly. That's right. Yeah. So let me open the one and let's get to the mean first. I need to find out the mean first. Let me share the screen right here. So I'm going to paste the entire data set here. And let's scroll down a little bit. So we need 2 columns, right? In order to calculate the mean and the standard deviation, just 2 columns is enough. Put in 12, center everything, load it, and then put all borders. So here's the total below that. The total here. The first thing is if you add up all those numbers, you get a total. The total is what we need. Right? In order to find the mean, we need a total. Get a total first. Total is 261, right? Yeah. And
Well,
then if
you didn't highlight the 42.7, so I don't know if it counted in there.
No, it does. You see,
Oh, it
by
does?
default, yes, by default. Although this is all highlighted, but 41st number usually won't be highlighted automatically.
Oh, okay. I didn't
By
know
default,
that.
you'll be highlighting, you'll be highlighting. But if you just highlight those, yeah, I did highlight that. But it just doesn't show here.
Oh, okay.
That one is always gonna be like that, right? So, but it's highlighted, so we get 261. That's a total. So if you divide this number by 7, you get a mean. So the sample mean equal 261 by 7, right? Got it? Or maybe, you know what? I'll let you guys try this first. Like, everybody try this question first. And then after that, we go over solution together. I think that will work better. Just like I just show you the solutions, it doesn't help too much, right? Let's do this, right? You guys try this question really quickly, finding mean, standard deviation, and variance in 5 minutes. And I'll go over solution in a bit.
Uh, um, Professor, so,
Yes.
uh,
Yeah.
so you were doing the number 6 one, or you just put X value just, okay,
Yeah, we are doing question 6 from the
Oh,
home
okay.
assignments.
okay,
I think
okay.
everybody probably have different version. Question
Okay,
maybe,
okay, got it. Yeah, now I got it.
yes, it's from the home assignment. Okay. Let's go back here. Okay, so finish yet? Let's go with a solution, right? So start with let's get all the work, prepare work. So prepare all the work. So get out the x squares, right? So we're gonna just square the numbers here. So get all the numbers. That. Now we get the total sum. This is a very large number, so it's so much easier using the Excel. I'm gonna copy this, and then from here I will show you guys how to do it step by step in the note. It's the whole thing. Okay, so I have the table here. So let's go from here.
How many numbers do we go to after the decimal?
How many number? You should keep all the numbers.
So if
In
it
this
was,
case,
so 03 with the line on the top for running 3?
and you mean which variable are you talking about? Do you mean the mean or standard deviation?
I was talking about the variable.
The variance.
Variance, yes.
Yeah. Okay. So first of all, that's yes, you're gonna keep exact answers. Right? It's possible if it is that's
Okay.
possible. But yeah, so let's see. So the mean is gonna be x bar. The total of x. You have that. You use Excel to get a number. So it's 261 over 7. Right? And let me see. How many decimal do they want? Is that specifying the question? 2 decimal places, right? So that two decimal is enough. So that means the mean should be equal to approximately, this is second decimal, third decimal is 5. So this is approximately 37.29. We get a mean, right? And then standard deviation, before we get to the standard deviation, let me just rewrite all the even numbers here. Did the prep work. So the total of x is 261. Total of x squared, it's 10,033.6. And sample size 7. On the standard deviation formula, if you want to get to the variance, right? Variance is s squared. So that means it's just going to be n times total of x squared. It's before you take in the square root, that's a variance. So minus total of x squared over sample size plus minus 1. Now using this formula, we can throw in our numbers. Sample size 7 times 10,033.6.
Oh.
Yeah, makes sense.
Yeah, I think what I got confused with was that you were multiplying n times the x squared. I didn't know you did that.
Total of x squared. Which one? So we multiply sample size 7, right? And then total of x squared is this. Sample size is 7, so then multiply that. Total of x is this, 261. So that's going to be 261 squared. That's on the top. The bottom is just going to be 7 times 7 minus 1. Make sense? And again, all this work, it's easier to complete it in the Excel. Or the calculator, if you decide to go with the calculator, feel free to do that. So let's compute the variance here. So it will be equal to, right? Make it bigger. Okay, let's see. So equal to 7 times 10,033.6 minus 261 squared. And dividing by denominator will be 7 times 6. Okay. And that will do it, right? We enter, get the result. We run it to decimal place. Yes, all right. It's gonna be 50.34. Yeah, 50.34. This one is 37.20. That's all we need, right? 50.34. I think for the standard deviation, you probably want to keep slightly more decimal. And that will make sure the standard deviation is slightly more accurate. So you take that number, that kind of number. And so this is
Professor,
approximating.
if you don't
yes.
mind, can you repeat the variation, how you find the variance? Also, the S square is variance, right?
S square is variance.
So n is 7, then x square is like the number of the 10,000, 1 lakh.
Mhm.
Oh, this one is okay, and
Yeah,
then
that's right. Yeah,
oh, okay, 261.
yeah,
And
261.
and we have to equation this. Okay, okay,
Mhm.
okay,
That's right.
okay. Thank you,
Okay.
Professor.
No problem. Yeah, you got it. So this is approximating. So again, we only need 2 decimal places. So it's approximating equal to 50.34.
We will not gonna do the root. Just this answer is the variance.
This is variance.
Okay. If
So
I do
usually-
the
Mhm.
root, then it is gonna be a standard deviation.
That's right. We're gonna get to that in a second. So standard deviation is basically just square root of that.
Yeah.
We can do square root of this whole thing here, right?
Mhm.
So be
Then
7
we got the
times.
answer of the
That's right.
standard deviation.
Yes, you get an accurate answer.
Yeah.
We'll do that one more time in Excel. So 7 times 6. Yeah, so let's put into the Excel.
Thank you, Professor.
Yeah, anytime. So go back here. So standard deviation, SD. Okay, so we're gonna do step square root. And, the top will be 7 times 10,033.6 minus 261. Square that. Dividing by 7 times 6.
Can't you just do the square root of the 50.34?
Yeah, you could do that.
Oh,
Sure.
okay.
Totally,
Oh.
right? If you want to do that, just make sure to keep at least 4 decimal place. So I'm gonna put in 6 decimal place, 3095. Right? If you put in more decimal, that means your answer is more accurate. That's why more decimal is better off. And that's why instead of putting 4 decimal place, I put in 6 decimal place. Yeah, so he entered the results, right? But in terms of running, you only need 2 decimal places. So we're gonna just run it to 2 decimal place. And then is probably. Then trim down to 2 decimal. Now be 7.09. Yeah, so that's what we need for that.
Professor,
Yes.
for the same question, I start for the population.
Yes, so we're gonna get to that in a second, right?
Okay.
So we take care of the sample, and then the follow-up question they're asking us, what if it's a population? Then, yes, what if it's a population and you want to find out population standard deviation? Then there's only one formula we can use for the population standard deviation. And then we got to use the mean in this case. That means go back here. Okay, so now population standard deviation is called mean, sigma, right? For the population. You can look up this in a formula sheet. It's equal to square root of total of difference between x minus population mean squared Okay, my population size. So you treat this entire data set as a population. And then we have the mean, right, which is the mean. So the population mean in this case is 37.28571429. And then population size 7. Now one more time, I think it's easier using Excel. I'm just going to quickly show you. I'm going to copy this one more time. And then we're using a different formula, so that's why we're going to put it side by side so you can compare them. And then mean, right? You put mu here. Go to insert. Insert a symbol. You're going to locate the mean, mu, in the symbol here. Where's the mu? It's right here. Insert that. Okay, the mu, and then the last one is x minus mu square, right? I'll copy this. Paste it.
Excuse me, have you taken attendance yet?
Not yet. I will do that as soon as I finish this question.
Okay.
All right. Once we finish the question, I'll let you guys go. Go back to the page. Center everything. Rolling. And then let's bring all of this. Now we need the mean. Let's get that. So we already find the mean, right? Mean is this. So we're just gonna do mean equal to total of this by 7, right? So you can do sum of all these numbers divided by 7. Look at that, 37 point something like that. And we're gonna just put a up for reference. Dollar sign. Dollar sign. Dollar sign here, dollar sign here.
Why we put dollar there?
Because we're gonna lock the cell, because you want to Excel to always go
Without
back to-
dollar, I do usually. Okay. Without dollar, it's not to be work here.
Yeah, we want to make sure they are the same. But if you do not put a dollar sign, I'll show you quickly. Then your answer will be totally off. If you drag it, you see it's not the same.
Okay,
Makes sense?
Professor, thank you.
Yes, so that's why dollar sign is very, very important here. And so we're locking the cells, right? Locking all the cells. Now we get these different squares, right? So we're going to do equal to this number minus this one. We do not need dollar sign, right? Because every calculation is different. It's based on the previous cells, so no dollar sign needed.
Professor, I have a question.
Sure, go ahead.
I do this formula like the same formula, but I take it summa x minus mu and like I forget how is it called, like multiply 2, not multiply 2, like
Not multiply 2. It's the to the second power.
it will be not correct if I take it not like every x. I didn't result every x. I took whole weeks, summa whole weeks, what we have before, 261 minus mu mean. And
No, you can't do that. No, that's not.
I can do it. Yeah,
No, you
this
can't
is
do
why I
that.
was wrong. Okay.
Yes, that's why you made a mistake. This is only way to do it. No other way. Right. So basically you can use the total.
This
You
is
can
why I
subtract.
was wrong. I took a total like 261 number.
Mhm. Yeah, you can use that. That's right. Right. So that's not allowed. Yes.
Thank you,
It's the
Professor.
only way to do it. Yes, that's very good. No problem. So that's a number we have, and then we're gonna get all totals, right? This. Now we need a total. We need this We're gonna get an auto sum here, the total here. So this is the total we need. That's the only thing we will need, right? In order to get the population standard deviation here. So one more time, I'm gonna copy this table. Now I'm gonna paste into the this file here. Let's see when I can paste it. I can paste it here. Yes. Now this is the only number we need, right? This one will go to the top. What's here? We're gonna put in this number, which is 302.0285714. Copy the entire thing. Divide by 7. That's gonna be our standard deviation.
Perfect.
Mhm.
Another question. We don't have to like take off whole numbers, stay only 2 after point, like 300, 0, 2 point, all 3. We have to
No,
whole number.
you should keep as many decimal as possible. Because if you just run it through decimal, your answer will be slightly off.
Because simple we do before.
Only the final answer you can run it.
Okay.
For all the middle calculations or the intermediate results, you shouldn't run it.
Okay.
Make sure it's accurate as possible. Then you don't make a mistake, right? The system will mark you correct. So here's a sigma, right? So we're going to insert a sigma here. So the population standard deviation. Let's say 16. And the calculation here is you're gonna take this. You're gonna do square root. If at least like 4 decimal, right? Minimum 4 decimal, but I will copy whatever I see over there. So 0.2855714. More decimal, the better it is. Divide by 7. Okay. And that should give us the accurate answers. If you enter, you get a 6.57. Yeah, that will do it. And that's the population standard deviation, right? 6.57. We only run it, you see, we only run it at the end.
Yes, I see. Thank you so much, Professor. I
No problem.
mistake.
Okay, very good. Yes. So 6.57. And yeah, so basically that's putting all the answers here. Okay. Let's start with the yes, it is. Okay. Yeah, on this question here. So the first number is 32 point something. Just double check really quickly. So 32.27, 29, 32.29, 50.34, 7.19. 37.29. Going, let's see, this is good, right? 37.29. 7.09, that's what we got. And that one is 50.34, that's what we get. And a standard population standard deviation 6.57, right? It's all good. And that's all the correct ones. They're all good. Now, yeah, so basically, I want to end the class here. So I'll see you guys on Monday, right, in class. So we go back to the classroom on Monday. Now, hopefully, no more Zoom class. So, yeah. Okay, so but if you have any question, you can stay after this.
Professor, we don't have a class not next month, Monday, like after next Monday, yes, 19th.
That's right, on 19th, right? On 19th is a holiday.
Yeah, okay.
We don't have class on 19th, but don't worry, I will remind you next week in class, right? Don't worry, you won't miss it. Okay. Yep. So yeah, that's it for today, right? If any questions, stay afterwards. Otherwise, have a nice weekend, guys.
Did you get the attendance?
Yes, I'm gonna do that right now. So before you leave, and let me quickly call attendance.
Okay.
I know who is here, but I just want to make sure we get everybody.
Professor, we have to submit assignment 3 before like next week. If I have any problem, then I can talk to Monday and
Yeah,
then.
sure. Talk to me on Monday. Yeah.
Oh, okay.
Yes. Talk to me on Monday if you have any question. But
Okay.
you remember, you can keep redoing this. I
Yeah,
didn't
yeah,
put a due date
exactly.
there.
Exactly. What I'm doing. If I find any problem, then I will go to Monday. If I don't find any problem, I will submit it.
Okay.
Okay. Thank you, Professor.
Yes. Yes. The only body we don't know is who is Fernanda.
Maria.
Maria.
Fernanda
Maria.
second
Okay,
name,
gotcha,
yeah.
Maria. So yeah. So basically, I get everybody's attendance. It's good. Just make sure that it's you, Maria. It's good. Okay.
Thank you.
No problem. I'll see you guys on Monday.
So you took the attendance?
Thank you.
Yeah, I did. I just did. Okay.
All right, thank you.
Good. No problem.
Yeah, have a good weekend.
Have a nice weekend, guys. Bye-bye.